So now I want to understand the logic behind the operation, and it is based on very simple the day one theory of how will you plot a graph. You know, input output, and that should be enough to get you started. And secondly, instead of thinking of it as a whole function, I'm thinking this function minus this function. This is g of x, I'm just naming it g of x, and this is h of x. This is a way of writing a function, right? So I can give my own name. So this is in red color. I don't know the color will be available or not, nor is it very important. The clarity of concept is more important. And minus h of x, which is in blue color. So let me observe what is happening in the story, and let me again think of my regions. There is a region beyond 5, there is a region behind 3, and there is a region between 3 and 5. And now let's see what will happen to fx depends on what is happening to gx and hx. I will also try and put numbers here. Beyond 5, I see that this line is going up. This line is also going up. And for each line, the slope is 1. Whether it's 1 or 2, the overall logic will remain the same. Slope is 1. What does it mean? That means if you go from 5 to 6, the value of this graph will change by 1 unit. There will be a plus 1 in the y. Whatever is the value of y here, this value will be, the new value at 6 will be y plus 1. So let's calculate values as well, and let's go step by step. The value of h at 5, right, is going to be 0. The value of g at 5, 5 minus 3 will give you a 2. So catch up that as well, will be 2. And the value of the overall function is gx minus hx, so 2 minus 0, the value will be 2. And why is that? Notice it visually also. At x is equal to 5, this point is 0, right? This function is 0. But at x is equal to 5, the red graph, the value of overall value of the output of y is equal to 2. If I make the new graph, it will be so. I'll point it here as of now. So with my black pen, I'm finally trying to plot this graph, right? So these two graphs are interacting, and I'm trying to create a third graph out of their interaction. Everything is on the screen right now. I'm going for the table values as well, right? This is at 5. Now let me get back to the slope again. If I go beyond this point, this value will increase by 1. This value will also increase by 1. But you're doing a subtraction, this from this. So a plus 1 in this and a plus 1 in this, but there is a minus in between, they will get cancelled, and the output will remain the same. So for example, now if you find the value of the function at 6, so you will say 6 minus 5 will give me a 1. So instead of 0, this has become a 1. And now if you find the value of g of 6, you will see 6 minus 3 will give you a 3. So 3 minus 1 again 2. So notice what is happening. This graph is going up by 1 unit. This graph is also going up by 1 unit. That means the distance between them will remain the same, because my salary goes up by 100 rupees, but my friend's salary also goes up by 100 rupees. So whatever was the difference between us will always remain the same. So as you keep going up in the story, if you go from 6 to 7, this graph is going up by 1 point, this graph is also going up by 1 point, but you are interested in the difference. So each participant, each member got 1 point. Whatever was the subtraction earlier will remain the same, right? So again, hit pause and try and internalize, verbalize, play with the story. Be very clear about what I am saying, because after that is a nothing idea, right? So now notice the graph. At 5 the value came out at 2. At f of 6 also the value is coming out at 2. So at 6 I'll again make it 2. So again like this. And now I leave the journey to you. You keep plotting. Your final graph will come out like this. So your final graph will come out like this, right? That the value of fx is not changing at all. And we started off with this example. We saw slope minus slope. The slope was getting cancelled. The slope is 0. The value remains the same. And why is that happening? This is changing by 1. This is changing by 1. For each value change in x, they are changing by the same amount. So whatever was their subtraction at this point, basically this distance is the same as this distance, right? It will remain the same throughout the eternity. And then if you have understood this, the same thing is happening on the other side. This line is going, if you want to follow this orientation, going up by 1. The slope is 1. This line slope is also 1. As you move beyond 3, whatever is this distance will remain. Though it might not look, these lines are supposed to be parallel, just the way they appear here, right? So again, If you have understood, great. If you have understood approximately, okay, I understand visually what is happening. In fact, it's not too much. You spend 5-10 minutes more and you will work it out on your own as well. So I've given the task to you that this is what we are thinking about. Beyond 5, this graph and this graph is giving you this graph as the output, right? What is happening between 3 and 5 is very interesting because it can also come in handy. Between 3 and 5, I notice that this line is going down, but this line is going up. And then again, think about what does that mean? That if you go in this journey, if you change the value of x, say you go from 3 to 4, please, you can always create a table for yourself as long as your basics are clear, and always think about it more physically, internalize it in your body. If I change the value of x, I know this graph is going up by 1 unit. So I'm trying to find the difference, right? If this is a and this is b, the difference is a minus, the difference is going to be a minus b at x is equal to 3. You go to x is equal to 4, what are you getting in the story? This. So move in the story, as you go from x is equal to 3 to x is equal to 4, what is happening? If this is the point A, you are seeing that it is going down. That means the new value is going to be a minus 1. The new a is this, a minus 1. What is the new b? The new b is b plus 1. Now you have to find the difference between them and put a bracket here to be accurate. So if I open the bracket, this will become minus b and a minus 1. So I see a minus b minus 2. And what does this mean? You started with a minus b and now you have a minus b minus 2. And why is this happening? For 1 unit change in x, you are getting a drop of 2. That means between this region or between the points 3 and 5, the slope is going to be, and that means the slope is going to be minus 2. So think about it carefully. What is happening here? Observe the line. The slope here, if you think technically, is minus 1. The slope here is plus 1, right? The slope is plus 1, but between the equations there is a minus 1. So minus 1 and a minus 1, my overall slope is going to be minus 2. So stay with this idea, and that's why we were not interested in the middle region. Beyond the extreme points, it is very consistent. That you just have to worry about both the lines going up or both the lines going down. In this region also, you can figure it out. It doesn't take too much time, but it's not as shortcut worthy. You'll have to think a little. Okay, this line is going up, this line is going down, but there is a subtraction in between. So how is that going to impact? And I've also looked at how to figure it out, how to use a and b and then start thinking, right? So that's the approximate foundation idea behind what we were doing in the previous examples. Why the slope was working out like that? Why did I just consider slope minus slope and I knew that it was going to be constant? Because I've seen mod graphs earlier. I sat one day and I observed that in any story, this is what happens. After this point, they behave in a certain manner and they have their slopes fixed, right? And that is just visible to me here. This is the region I have to be careful about, because in this region, the slope is not 1, the slope is minus 1 for this story. For this region, in this region, the slope for this is plus 1. But beyond this region, for both of them is minus 1, or for both of them it is plus 1, right? So that's why we do not consider this, we go beyond the extreme points only. But conceptually, we know, we can think about what is happening in the middle regions as well, though it gets a little more complicated than the simple process here.